Good evening, ladies as well as gentlemen. Papa Boris here with some more human resource management. Not management, human resource machine! Human resource management is a thing, but that's not this game. We just finished up number 17 in the last video. There is no number 18. 18 is a video. So I guess the numbers are a little bit misleading. There aren't quite as many puzzles as the numbers would suggest. But anyhow, we're gonna go to 19, and you might be like, wait a minute, Boris! Why are there dots next to the 19 and the 20? We haven't done those yet. Yes, well, I tried to record this video and failed spectacularly. This is a hard game. I hope you believe that now if you didn't believe it before, but let's try it again and see if I can do a better job explaining these puzzles. So, this is puzzle number countdown. Puzzle number 19, which is countdown. There we go. In this puzzle, your objective is to take the number and then output it as well as all the numbers between it and 0. So like if we were to do 9, it would be like 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Now that's pretty easy. The thing that makes this puzzle difficult is it's also actually possible to have negative inputs. So if there's a -2, for example, we have to go up to -1 and then up to 0 and then stop. So it's quite a tricky puzzle. Now we do have some new commands here, the bump commands, which are very, very important. So I'm just going to show you what those do. Let's take a number from the inbox, copy it. When you bump a number, you increase its value, and this is important, you also take the new value into your hand, which is usually a good thing, but it's sometimes a bad thing because you lose whatever you were holding in your hand previously. So I take 9, I copy it, and then when I do the bump, two things actually happen. Number one, the 9 becomes a 10, and then I put a 10 in my hand. So that's automatic, you don't have a choice about that. But it's like 2 steps in one, which can sometimes be a good thing. Now obviously bump down is the exact same, except you decrease the number by 1 instead of increasing it by 1. So, how exactly do we count down or up through or to 0? There's 2 different optimization challenges for every puzzle. There's performance, speed, and then there's program size. Usually one or the other will be more natural to figure out first, but it's not always the same one. So for this puzzle, I think personally the speed the performance optimization puzzle is more logical, so we're gonna do that one first, and then I'll do the speed one, or not the speed, then the size one after that. So here's what we do: we take a number from the inbox. Now, if this number is 0, then we're actually done. So we just put it in the outbox and move on to the next number. So that's really easy, and I think it is worth doing this jump if 0 check, just because you don't want to worry about the number being 0 later on. Now, if the number is not 0, then we copy it down, save it, and at this point we're also going to check it. Remember, the copy operation does not delete the number from your hand. I'm going to check the number. So if it's a negative number, then what I want to do is stick it in the outbox and count up from there. Like if it's a -8, I want to increase the number by 1 up to -7. So I bump the number up, and then I check it again. So if the new number is 0, then that means I'm done. So I'm just going to jump down here. I'm going to put the number in the outbox, jump back to the beginning. But if the number is not 0, that means all I have to do is just jump back here. So if the number is not 0, then I will deposit it in the outbox, increase it again, and then check again if it's 0 and repeat that process. So this is what I do if the number is negative, after I've ascertained that it is not 0. However, in here, what happens if the number is positive? Well, if the number is positive, I'm going to do pretty much the same stuff. I'm going to stick it in the outbox, except instead of increasing it by 1, I'm going to decrease by 1, so that I'm counting down, say from 7 to 6, then 6 to 5, then 5 to 4, and so on. And if the number is 0, then again, the same thing. I'm just going to deposit it in the outbox and start the program over. But if the number is not 0, then I'm going to jump back to the beginning, and not all the way to the beginning, just the beginning of this little loop here, where I deposit the number, decrease it, and so on. Now there's only one other thing that we need to make sure that we do, which is I need to actually copy the number back into my hand at this step, because let's see here. But actually, this doesn't. Wait, no, I think I just confused myself. Yeah, this should be fine. All right, so let's test it out. If it fails, then it totally fails, and that's my bad. But all right, so we take a 7. I'm gonna do it step by step for a little bit. I checked if it was 0. It wasn't, so I saved it. Then I check if it's negative. It's not, so I just keep going. I ignore the jump. Put the 7 in the outbox. I decrease the number, and this also puts the new number into my hand, which is convenient. I check if it's 0, it's not, so I repeat the process. And you can see this is going to definitely work. Okay, now when I get down to 0, I check to see if it's 0, it is, so I jump all the way down to the bottom, sticker in the outbox, and repeat with the next number. Now the next number is negative, so we'll do this one as well. One step at a time, I copy it, I check if it's negative, and it is. So instead of going to this segment of the code, I go down here, where I do mostly the same stuff. I outbox the number, bump it up to -7. It's not 0, so I outbox it, and then you can see this is definitely going to work. And when we get to 0, we go back to the beginning. The next number in the input is conveniently 0, so we see what happens here. If it's 0, then all I do is jump way down to the bottom of my code, submit it, and go back to the next number. Okay, so this should, I hope, unless I've screwed everything up terribly, give us the speed optimization. And it did. Okay, so 82 steps. I didn't exceed it, but at least I was on par with the fastest speed. But we didn't meet the size challenge, which is actually kind of weird if you think about it. It's like, well, how could I possibly use any fewer lines of code than this? Like, I check if it's 0, check if it's negative. How do I decrease the number of lines? And it's actually quite a weird solution. So here's what you have to do in order to save on size. Basically, in this program, I find out if my original number is 0, negative, or positive. And then I have a separate set of instructions for if it's negative versus if it's positive. But you might notice that these sets of instructions are actually really similar to each other. In fact, they're identical, except for in the negative case, we're upping by 1, and in the positive case, we're decreasing by 1. So basically what we can do is we can actually combine this into just one block of code. But then we have to check every single time if the number is negative, positive, or 0. So that's the plan. We take the number from the inbox, we copy it down, and we just send it to the outbox. Like, we don't even check if it's 0 or positive or negative. We just immediately submit it to the outbox. Now, once you put a number in the outbox, it's gone from your hands. This is why we had to save it up here. We have to save it because if we don't save it, we're just going to lose it. So then we pick the number back up, and now we check to see, what did I just put into the outbox? If I just put in the number 0, then that means I just put in the last number, so I can go back to the beginning and get the next output. If the number that I just put in the outbox is negative, then I bump it up by 1, and I'm going to jump back to here. So I put it in the outbox, essentially with this jump, and then I take the next number. However, if the number is positive, if it's not negative at this point, we know it's not 0, because we checked for that, so if it's not negative, it must be positive, then we bump it down by 1, and we jump again to the same place. So this is how you can do it on only 10 lines of code, but this is grotesquely inefficient, since every single time you put in a number, you end up checking whether it's 0, negative, or positive, and that's crazy because, of course, you should know if the number is negative. Like, I'm gonna take 7, save it, put it in the outbox, pick it back up, check if it's 0, nope, check if it's negative, nope. So then I decrease it by 1, put in a 6, and pick up the next number. And I'm like, is it 0? Is it negative? And it's like, I should already know that it's not negative because I already put in a 7. So like, if you're programming this efficiently, you should already know this is a positive number. You should not have to check every single time you pick up a number whether it's positive or negative. This is a really good illustration, if you are a nerd who cares about such things, of how just because your program uses the fewest lines of code, it's not necessarily the best written or the most efficient program. Because sometimes condensing your lines of code makes you repeat the same checks over and over that you really shouldn't have to. And you can see how badly inefficient this is. So in case you didn't believe me before, like in some puzzles in this game, like it really is a thing that there's no way to optimize both challenges. And in particular, that happens if there's a way to do it with fewer lines of code that's horribly inefficient. Like, then you're going to have to write a separate program to actually be efficient. In general, the speed challenge is more significant than the size challenge. But anyway, that's both of those challenges. So now we're going to go on to puzzle number 20, which is the multiplication workshop. This is actually, in my opinion, one of the hardest puzzles in the game. I had a really hard time with it. I'd like almost finished the entire game, and I still was having trouble with this one. All right, this is actually code for my failed attempt, so let's not deal with that at the moment, shall we? Here, the puzzle's extremely simple. Just take two numbers and multiply them. Piece of cake, right? Well, we don't unfortunately have a multiplication operation. In assembly language, I don't think assembly compilers have multiplication as a general rule, because multiplication is really just addition. So let me just do a little bit of writing here. If we have to do 2 times 3, this is really the same as 2 added to itself 3 times, or the same as 3 added to itself 2 times. So 3 plus 3 and 2 plus 2 plus 2 both equal to 6. A multiplication is basically like a shorthand notation for repeated addition. So the way that we're going to do this is we're going to have a few variables. First of all, the developers gave us the number 0, which is handy. Where I'm going to make oh yeah, this level actually I think is the first one where you can name your memory slots. It's like I can name this but, and then, you know, that way when I like copy from it or something, I know kind of where I'm copying from the but variable. So this is a way that you can like help yourself remember what each of your variables mean, and I do recommend if you're playing this game that you actually make use of that feature, because it's a really, really good one. So anyway, in the multiplication workshop, it's actually the reverse of the counting problem, or the countdown problem we did before. On the countdown problem, the more logical solution was the efficient one. And then you had to really think about how to get the size optimized. I think for multiplication, it's the opposite. The more straightforward solution is definitely the one that uses the fewest lines of code. And then you have to really think how to optimize it, because it's kind of tricky. That was the thing that I was stuck on for the longest time, and I admit I had to look up an answer online before I made this video to actually finish it. But anyway, here's how we multiply two numbers. So I take the first number, and I'm going to say that this number is my number. It's the number that I'm multiplying. So I'm going to copy it into two places, into the number and into the result. So basically, my number is 8, let's say, and my current result is 8. Now, depending on what the second number is, the result might be 8, 16, 24, 32. It's going to be some multiple of 8, but I'm not quite sure which one it is until I see the next number. So I'm going to take now the second number from the inbox, and here I'm going to do a quick check. I'm just going to say if this next number is 0, well, then I'm done, right? Because 0 times anything is 0. I'm just going to outbox it and go back to the beginning. So this is a completely functioning program if you assume your second number is 0. So the rest of the programming is going to happen in this space, which is what if the second number is not 0. So if the second number is not 0, I'm going to call it my counting variable. It's CNT, short for count. I'm pretty sure there's nothing else in English that has the letters CNT in that order, so this seems like a pretty safe variable name. Anyway, so here's my CNT variable. I copy it in, and now I'm actually going to bump it down right away. I'm going to bump it down. So at this point, I have to check to see if it's 0, because if I started with the number 1, I bump it down, it's going to become 0. If it's 0, that means I don't need to multiply my number by anything. So in that case, like, if I started with a 1, bumped it down, it became a 0, that means that my original number, in this case 8, is just the answer. So I take my current result, outbox it, and then I jump back to the beginning. And you might notice, kind of interestingly, I don't need to actually write outbox jump here, because it conveniently happens to be that the next 2 lines of code are outbox and jump. So this is just going to move on down and be totally fine. Now, if it's not 0, well, then that means I need to, actually do one more step of addition. So I take whatever my current result is, add whatever my original number was, and copy that to the result. So like I take 8, add 8, add them together, get 16, and then I copy that to the result. The reason I need these 2 variable slots is I need to make sure I remember what my original number was, because the next time, if I have to keep on adding, I'm going to take 16, and I need to remember that my original number was 8. If I just have a 16 and no 8, then I'm not going to remember how I got to the 16. After I copy to the results, I'm going to jump back here, where I bump the count down and check to see if I've gotten to 0 now. If I have, then that means I'm done. Otherwise, I have to keep on going. So let's go ahead and take it step by step, because this is a fairly complicated thing. Here's my 8. I save it, and then I throw it away. Then I take the 5. It's not 0, so I gotta actually do some work. I save it to the count, and I bump it down right away. It's not 0, which means 8 is not the answer. So I copy my result, add my original number to it, store that as the new result, and I repeat the process. Okay, still not 0. That means I have to do a little bit more addition. Copy 16. Here you can see why it's important to have remembered the number 8. If I didn't have this saved, I would not know that 8 was my original number at this point. So my new number is 24. That's 8 times 3. But as you can see, the count's not done yet. So I take 24, add 8, save it, bump the count down to 1. Still not 0. So I take result, add the number, save it. And here is where I finally get down to 0. So at this point, it means that I'm finished with multiplication. I just take whatever my result is. This is the wrong command. I did copy to instead of copy from, so this is going to be wrong. I'm going to deposit a 0 in the outbox and get yelled at by my manager. Yeah, that was a simple mistake, though. We're going to copy from the result, not to the result. Okay, so I don't think we need to watch all that. We can just fast forward through this. Okay, that's a long one. Jesus, 9 times 7. Okay. I do want to show you the next one, though. This one's an interesting one. So we deposit our 9 times... Actually, 9 times 8, 72. So I take my next number. It's 3. All right, I'm getting ready to multiply. But look, my second number is a 0. So I jump right to the outbox, because anything times 0 is 0. Now you're going to notice something interesting here. The next number has a 0 first. And I actually don't know this. So I take my 1. Now 1 is a pretty small number, so this isn't going to happen too much. But like if this was like an 8, I would end up adding 0 to itself 8 times before finishing the program. And you might say, well, that's kind of silly. Why don't you just check if the first number is 0? And in the more optimized version of this program, I definitely will. Because obviously if the first number is 0, I don't want to add it to itself 9 times. I just want to find out if it's 0 and deposit it. Alright, so that's 5 times 4 is 20, and we're done. And I hope I didn't screw up so that this actually works. Okay, so we got our size challenge of 15, but notice it's really not optimal. It's quite a way off from optimal. So what's going on here? Well, let's go ahead and take a look at the optimal solution. So you might notice, in fact, you might have even realized as I went along what the problem was and why our solution isn't optimal. It's not just because we're not checking for the 0. There's actually something much more fundamental. And if you do see it, then congratulations, you're smarter than me, because I did not see it for a long time. I had to look it up and figure it out. And then I was like, oh my god, that's so obvious. I'm such an idiot. Anyway, here's the deal. Say we have 7 times 2. My current version of the program, I'm going to say 7 is my number and 2 is my count. So I'm going to say 7 plus 7, get the answer of 14, and then I submit 14, and great, that was fast. But if it's given to me in the opposite order, if I'm given 2 and 7, then I'm going to just assume that 2 is my number and 7 is my count. So I'm going to do 2 plus 2 plus 2 plus 2 plus 2. Like, I'm going to take, a lot more steps doing it this way than I would have if I had just done 7 plus 2. So the key to the optimal solution to this problem, from a speed perspective, is to just figure out which of your two numbers is smaller and make sure that number is the count. Don't just assume that it's the count. Now, unfortunately, with these inputs, the first number is always bigger, so it's kind of tricky to actually do that here. I don't think we're going to be able to actually see this optimization in action, but I'll be able to explain it through the code. So I take a number from the inbox, and now I'm actually just going to check to see if it's 0, because I don't want to add 0 to itself a bajillion times. Now, here's the tricky thing. If it's 0, I can't just outbox it and go back to the beginning. I can't do that. The reason is that there's a number pair here. Like, say this number was 0. If I put it in the outbox and then went back to the beginning, the program would treat 4 as the first number of the next pair, when really it's the second number of the first pair. So I have to do one other thing here. I actually need to take the next number from the inbox and basically throw it away before going back to the beginning. Now, assuming the number is not 0, then I'm going to do a similar thing to what I did before. I'm going to copy it to the number, and I'm going to copy it to the result. And I'm just going to, assume that it is the bigger number for now. Then I take my second input. This one, again, I'm going to check to see if it's 0, because I don't want to worry about zeros later. If it is 0, then what I can do is send it to the outbox and jump back to the beginning. This time I don't have to worry about throwing away the next number, because this number is the next number. So I have two kind of very similar lines of code. outbox jump and outbox inbox jump, but I've not been able to figure out any way to combine these two together, and I suspect there isn't a way. You just have to deal with it. Okay, but if the number is not 0 here, then normally we would start doing all this, crap, just to, basically we save it as the count and we do all the work and whatnot. But here we're actually going to check to make sure that the second number really is smaller than the first number before we assign it as the counting variable. And you might remember how to check whether a number is bigger than another number. You use subtraction. So I take the number that I'm holding, I subtract it from the original number, and now I check to see if it is negative. And if it is negative, then I'm going to do all the stuff that I normally do. All right, so this is like basically all the exact same stuff that I did before. I'm gonna first of all add the number back to get the original number back to my hand. Then I'm going to copy it to the count. Then I'm going to bump the count down by 1. If it's 0, that means I'm done multiplying. So I'm going to basically copy the number from the result, because the current result is the answer. And then I'm going to, outbox it, go back to the beginning. But if the number is not 0, then that means I have to do the multiplication. So I copy from the result, I add the number to the result, I save that to the result, and after I save it to the result, I have to jump back to the beginning. Hope I'm doing all this right. I think I need to go back to here. Yeah, that makes sense. Because I need to decrease the count by 1, and then if it's 0, I stop. Otherwise, I keep on going, etc. So this is basically all the stuff I'm going to do. It's just the normal stuff I did in the previous program. In fact, this is a case where using the copy-paste feature might have been helpful, and I will do that if I screw this up somehow. But basically, this is all the normal stuff that I did in the original multiplication code. But if it's not negative, that means that the second number is actually bigger than the first. So we have to swap them, and swapping is actually kind of tricky in assembly. It takes a lot of steps, because if you write over the old number, then you lose the old number and you don't know what to put in the first number's place. So I get my number back by addition. I save it to the number spot, because this is going to be my new number, but I can't save it to the result yet, because if I do, then I'm going to forget what the other number was. So first, I have to take the first number and save it to the count. Then I copy from the number which I had saved and copy it to the result, and I'm in business. At this point, all I have to do is jump to this part of the code here, where I proceed to do the multiplication, bumping down the count, etc. So hopefully I didn't screw this up. And again, unfortunately, none of these number pairs actually show the swap happening, so we'll just fast forward and hope it's not screwed up to hell. Let's see. So here we have a case at least where it's 0, so we save the 3, pick up a 0, it's 0, so we just deposit it and go back to the beginning. Here we have a case where the 0 is first. Oh geez, what just happened? Okay. That's definitely not what I wanted to do. Hang on a second. Did I really have this jumping to the wrong place? Oh yeah, I have this jumping to the totally wrong place. Wow. I don't know how that happened. It needs to jump, here. Yes, that's where it needs to jump. Okay, so let's hopefully it didn't screw it up this time. Oh wait, we actually have a case where it's swapping now with this new set of inputs. Okay, so here we save the 1. Alright, then we realize, hey wait a minute, 8's actually bigger than 1, so I want to swap them. So first of all, I add the 1 to get my 8 back, save it to the number, pick up the 1, make it my count, pick up the 8, make it my result, and now I proceed with the multiplication. See, I'm done, because it was just a 1, so I take my 8, and then I outbox it and jump, and this is much faster than if I had added 1 to itself 8 times. So hopefully I didn't screw up the stuff with the zeros. Well, I guess the proof will be in the pudding here. Okay, everything's fine. Hopefully it's actually optimal. It is! Ah, thank God. Okay, so size-wise, this program is horrific, but speed-wise, it's great. We succeeded on the optimization, and we are ready to continue on to our next puzzle. Wow, that was actually a really long video. I am amazed how long it took to do those 2 levels. So we'll do the next 2 levels in the next video. Thank you guys so much for watching. I hope you enjoyed it. Please like and or subscribe, and I'll see you again soon. Take care.